Okay, so where we left off yesterday was we were given the function f of x equal to 2x cubed plus 1 quantity cubed, where the point 127 is on the curve. And so you're asked to find the derivative of the inverse function at 27. Okay, so in order to find the derivative of the inverse function at 27, which is what we're looking for, so that's here, we are required to find the derivative of the function at 1. Okay, so we need, so we're looking for the, so this is what we're looking for. And this we're going to call m. All right, so our unknown is the derivative of the inverse function at 27. And we need to find the derivative of the function at 1. And then after we do that, that value is m. And then the answer to this problem is literally just 1 over m. Okay, so this is one way I want you to think of these problems. If you are given a function, here's f, here's f inverse, and you are required to find the derivative of the inverse function at 27, that's going to be 1 over m, where m is the derivative of the original function at 1. Okay, so can you please compute that for me now? The derivative of the original function and evaluate that at 1 and let me know what you get. Okay, so what is m? I think some people are still trying to take the derivative of f of x. Anybody have m yet?
I have a question.
Okay, Peyton.
So once you find a derivative of fx, you're adding 1 just to make sure.
Okay, then you evaluate it at 1. Okay, so you need to first find.
It's getting a little hot in here.
First find f prime of x. And then you find f prime of 1 and call that m. And then what we want, which is the derivative of the inverse function at 27, just becomes 1 over m. Okay, so f prime of x, what is f prime of x? Somebody want to give me the final version of f prime of x? F of x was 2x cubed plus 1 cubed.
Is it 3 times 2x cubed times, or sorry, it's 3 times 2x cubed plus 1 to the power of 2 times 6x.
I think you said it right. So is that Victor? I think you said it right. You said f prime of x. And you said 3 times 2x cubed plus 1 squared times 6x. Is that what I got from you?
Yes, sir.
That's right. Okay, that's correct. 6x squared, I apologize. 6x
Sorry.
squared.
Sorry.
Okay, yes. All right, so that's correct. That is the derivative. All right, we used the chain rule. So we took the derivative of the outside function, which is 3u squared, and then the derivative of u, which is 6x squared. Okay. So therefore we get f prime of 1 is 3 times 2 plus 1 squared times 6. So that's 18 times 9. And I love this when I don't feel like thinking. 8, I can just do 18 times 9. Okay, 162. So let me just make sure. So we took the derivative. So that was 3 times 2x cubed plus 1 squared. And then we took the derivative that gave us 6x squared. And so then the 6 times the 3 is 18. We put the 1 in, so we get 2 plus 1. So that gave us 3. 3 squared is 9. 18 times 9 is 162. So that becomes our M. Okay, I don't know why it keeps doing that. Don't get on my nerves. Okay, so this is now our M. So therefore, the answer to the question, the derivative of f inverse with respect to x at 27 is 1 over m, or 1 over 162. Okay, any questions? Okay, here's the last question from yesterday. Okay. And for some reason, I feel like I saw a 3 down there that doesn't belong. Yep, that doesn't belong there. Okay. All right, so how do we tackle this problem? How do we handle this problem? It's actually the same kind of problem as the last one. All right, so if you need a visual aid, I will give it to you. So here's the visual aid. Okay. So here F is going to pick up pi over 2. and take it to 2 over pi. All right. F of pi over 2 is the sine of pi over 2 divided by pi over 2. The sine of pi over 2 is 1, so therefore this is 1 over pi over 2, or 2 over pi. So F picks up pi over 2 and takes it to 2 over pi. And F, so this is F. And F inverse picks up 2 over pi and takes it back to pi over 2. All right. And I need to give you an interval. So let me give you an interval. This is only going to be valid on 0 to pi. Sine of x, 0. Oh, can't go to 0 to pi. Can't go that far. I have to go 0 to pi over 2. Sine of x over x. Let me see what that looks like. Let's do a quick graph of that. I think I need to give you an interval. Okay. So when x is 0, oh, I can do that. That's good. I can do sine of x over x from 0 to pi. I can do that. That works. It has an inverse. It has an inverse. So I can go from 0 to pi. Okay. So what do I want? Well, over here, I'm asking for this thing right here, which is the derivative with respect to x of the inverse function evaluated at 2 over pi. So that's what that is. And so we're going to know that that is 1 over m. And over here, where m is going to be the derivative of the function evaluated at pi over 2. Okay, does everybody see what happens here? So in order to find the derivative of the inverse function evaluated at 2 over pi, I know that's going to be 1 over m, where m is equal to the derivative of the original function at pi over 2. Okay, so that means we need to find that. So you want to find that, please. F of x is the sine of x over x. So find f prime of x. So what is f prime of x? EJ, I think you're frozen. Oh, there you are. Okay, so find f prime of x. And let me know when you have the derivative. And actually, you can go ahead and evaluate that thing. Okay, what's the derivative? What's the function? I just want the derivative, not it evaluated at 1, I mean at pi over 2. What's the derivative?
It's x cosine x minus sine x over x squared.
Okay, who was that?
Alexis.
Thank you, Alexis. Okay, that is correct. All right, so then what is f prime at pi over 2? So now we're
Four.
evaluating it at pi over 2, and what do you get?
For that, I got -4 over pi squared.
And I believe that's what I got. And so therefore that is m. So therefore what we are looking for, the derivative of f inverse with respect to x at 2 over pi is 1 over m, which is negative pi squared over 4. Oh, that would have made a perfect test question. The answer comes out all nice and neat. All right, any questions about this?
Yes, I'm confused on the last part, like how you got from like -4 over pi squared.
Okay, all right, so let's evaluate it. So let's do the evaluation. Okay, so that's going to be pi over 2 times the cosine of pi over 2 minus the sine of pi over 2 divided by pi over 2 squared. So now the cosine of pi over 2 is 0. All right, and the sine of pi over 2 is equal to 1. So this is -1 divided by pi squared over 4. So that's -4 over pi squared. Okay. Any questions about that? Okay. So at this point, I want to take any questions that you might have from the homework that you worked on in the last 2 days. We've covered everything from these sections. I know there was a question, a student came to office hours and had a question about how to find the domain and range. So whatever questions you guys might have, please let me know. You guys are good on everything? Hello?
I'm all right.
Okay.
I'm doing good so far.
All right, that's good to hear. Okay, well, I'm going to end this section, and since I'm going to go ahead and start the next section. If there are no questions about inverse functions. Oh, let me give you a, I know what I can give you as a more practice. Find dy dx. All right. Oh, that's a nasty one. Okay, we can start working on those.
This meeting is being recorded.
For the first one, I got 6x over the square root of 1 minus, in parentheses, 3x squared minus 4 squared.
That's correct. All right, who was that?
Mikhail.
Thank you, Mikhail. All right, so number one, we have y is equal to the sine inverse of 3x squared minus 4. Okay, so u is 3x squared minus 4. So when I take the derivative of the sine inverse of that, I'm going to get 1 over exactly what Mikhail said. 1 over the square root. My 1 disappeared. I got to put it back. Of 1 minus 3x squared minus 4. Three x squared minus 4 squared. And then he multiplied by the derivative of 3x squared and got 6x. So his answer is completely correct. It is 6x divided by the square root of 1 minus 3x squared minus 4 quantity squared. Very nice, very nice. Number two. Somebody other than Mikhail.
Sorry, I didn't simplify this part just yet, but I did, it was, or you could put in parentheses like 3x squared times the negative 2 times sine of 2x over 1 plus cosine of 2x squared. But if you simplify it to multiply negative,
Okay, all right. Victor, that is the almost correct, but that is the ultimate mistake. What did you do wrong?
Wait.
I give you a hint. This is one function, and this is another function.
Oh, u substitution.
No, you did the derivatives right, but what rule do you need to do?
Multiplicative rule or product rule.
The product rule. Okay, so it is So y prime, so y is equal to x cubed times the tan inverse of the cosine of 2x. So y prime, you did the derivative of the first, and then what comes next?
I took the derivative of inverse tangent, which was 1 over,
Okay, so it's derivative of the first times the second as it is. Plus the first times the derivative of the second. Which you got the derivative correct, but you didn't use the product rule. Okay. Do you see the mistake?
yeah, so next time so I just forgot the product rule.
Yes. Okay, so your derivatives were absolutely correct. So you would have gotten a good amount of points for the problem because your derivatives were correct, but you would have lost points because you didn't use the product rule correctly. Okay.
Thank you.
All right, so I appreciate your answering because I think that you're not the only one that made that mistake because a lot of people do forget the product rule, okay? But your derivatives were dead on. So what I really wanted to know was this. Could you take the derivative of this piece? And you did. Okay, any questions? So you guys are good on taking derivatives of inverse tangent function, inverse, all the inverse trig functions, along with the chain rule, product rule, quotient rule, and whatever else is involved. Okay. All right, I'm going to go ahead and start the next section. Normally, if you had a
Another example first, please.
what's that?
Can we do another example?
Another example?
Another practice, yeah, please.
Okay. Actually, I'll be nice. Oh, no, let me make it something. Well, y'all already started the problem. Okay. There you go. So now you have two problems to do. Anybody want to talk me through it?
Through both of them.
Well, one of them.
Try the first one.
Okay, Johnny, go ahead.
Let's see.
How do you do the first one?
Pull up my notes real quick. Oh, so the inverse of the wait, would the first one be the chain rule?
Yes, one use chain rule.
And it would be
So in that one, what is u?
x to the fourth.
Okay, actually u is the whole thing inside.
Oh, the sine x to the fourth.
Yeah, so it's actually a chain rule inside of a chain rule. So u itself is the sine of x to the fourth. So now you have to do the chain rule to find du. So what is du dx?
That'd be cosine.
Cosine, good, of x to the fourth. But you got to take the derivative of what's inside, which is
4x to the third.
4x cubed. Okay. So your du is pretty hefty because you had to use a chain rule on your u. Okay, so now you can come down here and you have y is equal to tangent of u, tan inverse of u. Okay,
Yes.
so now what do? What is y prime? You got it. This is dy dx. Y prime is dy dx. So you got to take the derivative of y with respect to u and multiply by your du dx, which we already found, right?
Yes.
Okay. So what is the derivative of y with respect to u? How do you take the derivative of tan inverse of u?
Oh, that'd be that would be 1 over 1 plus x squared.
Okay, it's going to be a u though.
Oh, 1 plus 1 u squared.
Good. And now you got to multiply by du dx, which means you got to pick that thing up, which is 4x cubed times the cosine of x to the fourth, right?
Yeah.
Okay, so now how do I finish the problem?
You put you put the sine x to the fourth in.
Exactly. Okay. Awesome. So I get 4x cubed, the cosine of x to the fourth. And then, as Johnny said, I put in the sine of x to the fourth, but that whole thing is squared. Okay. Johnny, that was awesome. Thank you. Because you certainly helped some other students walk their way through it. Okay. Anybody want to walk through number 4?
I gotta get to guess.
Okay.
You would first use a u substitution for as like for the in the outside brackets where you have u to the third. Or, yeah.
Okay, so good. So y is u cubed and u is the stuff inside. I agree with you on that. Okay, so once again, u is going to require a chain rule in order to do that, correct?
Yes.
Okay, so what do we do? What's du dx? Well, dy du, find that. That's easy.
That'll be 3u to it's 3u to the square, 3u squared.
Okay. All right, so now the du dx is a chain rule. So what do you need to do for that?
For inverse secant, it's -1 over the absolute value of x times the square root of x squared -1.
Okay, so
And
therefore I'm going to end up with, and actually the secant is not negative, the cosecant. Remember, cos are
oh,
negative.
cosecant. Okay.
So I agree, you have 1 over. I got to get the absolute value of 4x squared. And then I have to do the square root of 4x squared minus 1. And then what do I have to multiply by? I got to keep going in. So what do I have to multiply by?
You have to multiply by the derivative of what's of the like of the inners. You can parentheses or like 4x, or take the derivative of 4x squared, which would be 8x.
Good. Okay. All right. So now let's put it together. We get dy dx is 3u squared times. I can pull the 4 out. All right. So the 4 and the 8 give me 2x. But I cannot divide the x and the absolute value. They have to stay. So this becomes, oh, wait a minute, the absolute value of x squared is, the absolute value of x squared is x squared. Oh yeah, I can do that. The absolute value of x squared is positive. So the absolute value of x squared is just x squared. So this is still just x squared. And then I have the square root of 16 x to the 4th minus 1. Okay, so we're there. Now we're done. Dy dx is 3, so that's 6. U squared, that becomes the secant inverse of 4x squared. And only thing you can do is make that squared like that. And then there's an x. We're going to divide that out. So you get x, and then you get square root of 16x to the 4th minus 1. Okay, not cute, but that's what it is. All right. Any questions? Okay. All right, so that's it for today. Tomorrow we start a new section. So practice your problems and do what you need to do to review these 2 sections, because tomorrow we're on to something else.
I got a question.
Okay.
I don't know if I missed it, but when